Okay, so for my city that I picked in the Eastern and Northern Hemisphere, I picked Tokyo, and in the city that I picked for my Western and Southern Hemisphere, I picked Lima. So what I had to do is I had to find the hours of daylight in Tokyo and Lima. So in order to do that, I just went online and looked up those numbers. And so you can see the charts below for that represent just a couple of the months and the hours of daylight. So I figured out that in Tokyo, the minimum hours of daylight fell on December 21st, where there was 10.78 hours of daylight, and then the maximum of the graph was in August when there was 14.93 hours of daylight. And then for Lima, I figured out that the maximum of my graph was in January when there was 12.82 hours of daylight, and then the minimum of my graph was in July when there was 11.42 hours of daylight. So the first thing I had to do was I had to determine the equation for the hours of daylight in Tokyo. I got my equation to be y is equal to negative 2.075 cosine 2 pi divided by 365x plus 12.855. The reason I added the 12.855 to the end of the cosine function is because that is the value in the middle of the maximum and the minimum to the graph. I took the max and min and divided them by 2 to get this value, which is also known as Fred. I got the negative 2.075 by subtracting the value of Fred from the maximum value of the graph. This gave me the value of 2.075. The reason it is negative is because the graph starts at the minimum, which therefore makes the cosine graph negative. Finally, I found the 2 pi over 365. I found this value because I knew that the normal period of a cosine function is 2 pi, but I knew the period of this function had to be 365 to represent the days in the year. I also knew that the value that was multiplied to x is the same value that 2 pi is divided by to get the period. So when I divided by 2 pi divided by 2 pi divided by 365, I got my period to be 365, which is why the value being multiplied to x is 2 pi divided by 365, which also, that explanation also explains how I got my period to be 365. One important thing to note is for most of the important features, I had to add the period to the end of each of them. The reason I added 365 to each of them is to account for the fact that the cosine graph repeats over and over. This idea will be present throughout. Next, I found the minimum of my graph to be 0 plus 365k, comma 10.78 plus 365k. And I knew my x value was going to be 0 since the minimum of my graph hits the y-axis, and that the y value was going to be 10.78 because that's the smallest number of daylight hours. I found the maximum of my graph to be 182.5 plus 365k, comma 14.93 plus 365k. I found my x value to be 182.5 because it is half the period. I got my y value to be 14.93 because that is the maximum number of hours of daylight in Tokyo. I found the areas where it's increasing to be from bracket 0 plus 365k, comma 182.5 plus 365k, close bracket. I knew it was increasing at these intervals because it is increasing from the minimum of my graph, whose y value was 0, to the maximum of my graph, whose y value was 182.5. I found the areas where it was decreasing to be from bracket 182.5 plus 365k, comma 365k plus 365k. I knew it was decreasing in these areas because it is decreasing from the maximum of my graph, whose y value is 182.5, to the minimum of my graph, whose y value is 365. I found my graph to be positive from negative infinity to infinity, since you can't have a negative hours of daylight. For the same reason, my graph was never negative. There was no x-intercept of the function, since there was never a day when there was 0 hours of daylight. I got my y-intercept to be 0, 10.78, which is because on the day when the graph starts, day 0 is a day where there's the smallest number of daylight hours. I got the domain of my graph to be from negative infinity to infinity, since the graph repeats over and over without any restrictions on the x values. Finally, I got the range of my graph to be from bracket 10.78, comma 14.93 bracket. These values were found using the y value from the max and the min of my graphs. Next, I had to find the equation to model the number of hours of daylight in Lima. I had to determine the equation for the the number of hours of daylight in Lima. I got my equation to be y is equal to 0.7 cosine 2 pi divided by 365 x plus 12.12. The reason I added 12.12 to the end of the cosine function is because that is the value in the middle of the maximum of my graph. And then I got the 0.7 by subtracting the value that I got in the previous explanation, the 12.12, from the maximum of my graph, which gave me the value of 0.7. Finally, I found the 2 pi divided by 365 the same way that I found it in the function for Tokyo. Just like in Tokyo, the period is once again 365. And then I found the minimum of my graph to be 182.5 plus 365k, 11.42 plus 365k. I found my x value to be 182.5 because it's half the period, and I got my y value of 11.42 because that is the minimum number of hours of daylight in Lima. I found the max to be at 0 plus 365k, 12.82 plus 365k. I knew that the x value was going to be 0 since the maximum of my graph hits the y-axis, and my x value was going to be 12.82 because that is the largest number of daylight hours. I found the areas where it was increasing from 182.5 plus 365k to 365 plus 365k. I knew it was increasing at these intervals because it is increasing from the minimum of my graph, whose y value is at 182.5, to the maximum of my graph, whose has a y value of 365. I found the areas where it is decreasing from 0 plus 365k, 182.5 plus 365k. I knew it was decreasing these areas because it is decreasing from the maximum of my graph, whose y value is at 0, to the minimum of my graph, whose y value is at 182.5. I found my graph to be positive from negative infinity to infinity, since you can't have a number of negative hours of daylight, and for that reason my graph was never negative. There was no x-intercept of the function since there was never a day when there was 0 hours of daylight. I got my y-intercept to be at 0, 12.82, which is because on the day when my graph starts, day 0 is the day when there is the largest number of hours of daylight. I got the domain of my graph to be from negative infinity to infinity, since the graph repeats over and over without any restrictions on the x value. Finally, I got the range of my graph to be from 11.42 to 12.82, and these values are found by using the y values for the maximum and minimums of my graph.